Good morning, Year 8. This will be our first lesson on our new topic of acids and alkalis. So to begin with, I have 5 questions for you to do as a knowledge recall. So this is taken from 2 of your previous topics. So pause the video and give yourself at least 5 minutes to have a go at these, and then I will go through and explain some of the answers. So these are the answers to that knowledge quiz that I just gave you. The main points I would like to highlight is insoluble, that means it does not dissolve. So when we filter things, it's a bit like putting something through a sieve, like draining pasta from water. So your pasta doesn't dissolve in your water, so the water will go through the sieve, and what you're left with is your pasta in the sieve. So the same thing or the same principle applies with filtration. So your solvent or your liquid, that will pass through the filter paper, and then you will be left with your insoluble solid in the filter paper. The other one I would like to explain is number 5. So just emphasising this point that in chemical changes, we're talking about chemical reactions. So we're reacting substances together to make different substances, so different to what we started with. So an example could be burning something, and that's going to release carbon dioxide gas if it's a carbon starting material, such as a fuel, such as methane gas that we use in our Bunsen burners. Whereas physical changes, these are things such as our separating mixtures, like that filtration example we looked at, but it also can include things like state changes. So thinking about water as a solid, we know it as ice, but as a liquid, we call it water, and then as a gas, we call it water vapour. But actually, it's all still the same substance. It's all still H2O. So that substance has not changed, but the physical state of it has. So it's changed from being a solid to a liquid or to a gas. So we're doing a physical change going between those different states, but our substance is still the same. So this lesson is going to be on an introduction to acids and alkalis. So you will have come across some acids and alkalis in your everyday life, even if you didn't know you have. So before you begin, what I would like you to do is carry out the true or false quiz in that initial acids and alkalis worksheet that is attached on Go for Schools, so that we can have a look back at this at the end of our topic. So pause the video to have a go at that worksheet, and then return back to this video when you're ready to move on. So first example of an acid is Coca-Cola. Vinegar is also an acid. Lemon juice, you might have come across thinking about the term citric acid. You might have heard that before, and that's because all citrus fruits have citric acid in them. Tea is also a bit acidic, as is soda water. Alkalis as well, you will have come across, particularly bleach. You might have seen, you may not have used it yourselves, but I'm sure your parents have used bleach to clean your house. But you have more likely used these, so shampoo and soap. Toothpaste. May or may not have come across Gaviscon, but this is an indigestion tablet, and we'll talk more about that in a later lesson. And bicarbonate of soda, this is an alkali we use in cooking. So 2 different categories there, acids and alkalis, and we're going to look now at how we can distinguish between these in different ways, because actually, as we're going to find out, they have quite similar properties. So our acids, if we think about the particles that are making up acids have an H atom, shown here by that red circle, and in the formula we've got that H present. Whereas our alkalis, they have an OH. So there I've shown that by the red particle connected to the purple particle. So the red and the purple together, that is your OH. So when our acids and alkalis are in solution, they release those particles. So acids release H particles and alkalis release OH particles. As chemists, it's quite important to be able to tell between different substances. So writing formulas on our bottles will tell us what type of substance it is. So here you will notice in each of these acids, they have an H particle in that formula. And similarly with these alkalis, we have the OH particles in that formula for that lime water and the sodium hydroxide. So first activity for you to do is sort all of these different substances. Some are everyday, some are industrial, but they've all featured in these slides, into an acid or an alkali. Try and do as much of it as you can without going back. However, if you do get stuck, pause the video and rewind. And I'm now going to show the answers. So if you haven't quite, I'm not expecting you to have had time, but pause the video if you're still working it all out. And these are the answers. So I don't know if any of them were surprising to you, but you can let me know on Teams. And so we're now going to start to think about the properties. Now, we often get a lot of bad press when it comes to acids because of the dangers that are associated with them. But actually, alkalis are just as dangerous because they both have this corrosive nature. So corrosive means that they can damage or destroy other substances on contact. Warning labels are also there because they can cause irritation to skin, eyes, or respiration. So your respiration system, as a result of breathing in any vapours of these acids or alkalis. So that's why we can be quite cautious about acids and alkalis, and it can worry us a bit. But if we take safety precautions, then we won't be at risk. So what I'd like you to do is, thinking about those definitions for corrosive and warning, is I'd like you to come up with a design for the hazard symbols to represent corrosive and warning. So thinking about what they mean, design a symbol to illustrate corrosive and warning. Pause the video while you're doing this, and then I will show you what the actual hazard symbols are for acids and alkalis. But I'm curious about what you would use to represent those symbols. Those meanings, sorry. Okay, so the one on the left, that is our corrosive, and the one on the right is our warning. So in the left, you may not know what that black block is, but that is supposed to be a metal. So acids corrode metals. That's where that corrosive actually comes from, is because it reacts with the metals and wears away those metals as a result of those reactions. But what you notice in the right of that corrosive diagram is that it can do the same thing to our skin. And that's what makes it really dangerous if we are using acids of a strong enough concentration. That can be particularly dangerous for us. And this is where you might have heard of acids before in the press. Very rarely acid attacks can happen. But I do think it's important that we talk about this because we can talk about it from a first aid perspective, in a sense of what we would do if we ever saw this happen to someone, how we could help those people. So using clean water to wash away any of the acid that's got onto their skin, any contaminated clothing, that should be removed so it doesn't seep through that clothing onto their skin. In labs, so at school when we do practicals, we will always be wearing safety goggles, and that's to protect our eyes because it's our eyes that will be most vulnerable to. So we always use fairly low concentrations to try and protect ourselves, But as a further protective measure, we should always be wearing safety goggles to ensure that we are protecting ourselves. In the home, so we've talked about acids there, but remember alkalis, they are also corrosive. So if you're ever using bleach or chemical products that are strongly alkaline, then you should always be wearing gloves, because that's going to protect your skin from that corrosive nature of the alkalis. Now, I've mentioned a word here, and that is concentrated. So I want to talk about the difference now between concentrated and dilute. So here you can see two diagrams. One on the left has lots of particles, one on the right has very few particles, but they're actually in the same volume. So when we're talking about acids and alkalis, we often talk about them being solutions. So the acid or the alkali has been dissolved in water. And on the left, we see that there's a lot of H plus particles in the water, whereas on the right, there aren't that many. And that's the difference between concentrated and dilute. It's about the amount of those H particles that our acid has been able to release to solution. And similarly with our alkali, so it should say concentrated alkali versus concentrated versus dilute alkali. Apologies for that typo. So here again, we're talking about the release of OH particles in solution and the amounts of those. So concentrated alkalis, lots of OH particles being released, whereas in our dilute alkali, there are very few OH particles in that solution. So these two examples are specific to acids and alkalis, but we could be a bit more generic, talking about concentrated versus dilute. So I'd like you to draw me a diagram showing me the difference between something that is a concentrated solution and a dilute solution. So pause the video while you have a go at drawing diagram, just like you've seen on the previous pages, but you don't need to worry about whether it's H or OH, because you're just keeping it a generic concentrated versus dilute. So I'm going to move on, but obviously pause the video whilst you're still working on this. So we can buy detergents so particularly supermarkets and industry where they're doing a lot of cleaning. They'll buy it in a bulk high concentration solution, and they'll then dilute it down to that lower concentration that's safer for people to work with, more to the concentration that we would buy at supermarkets. So the way in which we can do that is we add water to that concentrated solution to make it more dilute. And you probably have done this before, not with detergents and not talking about acids or alkalis, but with squash. So with squash, lots of them sometimes advertise it being double concentrated, and that's because they put more of those flavouring particles in that same volume. But when you then add water to it, you are diluting it, because you're changing the volume overall whilst keeping the same number of particles, but you can see that difference in concentration by looking at the colour. So that darker colour that's in the bottle, that shows you there's loads of those coloured particles in that bottle. But then when you look at your glass that you've made up to drink, it's a lot paler, and that shows you that there's fewer of those particles in that volume. So can you please, where you have done your diagram for your concentrated versus dilute, can you make sure that you have written a sentence about how you can go from a concentrated solution to a dilute solution? So just like what you would do with squash, taking that concentrated squash in the bottle to that dilute solution in your glass. So pause the video while you do that. Okay, and we are going to finish up today with a true or false quiz. So true or false, lemon is an acid. Pause the video while you have a think. And it is true, lemon juice is an acid. So remember at the start of this, I said about citric acids. So things like grapefruit, orange, limes, they are also citrus fruits, and therefore they are also acidic. Next one, true or false, soap is an acid. Pause the video while you have a think. And the answer here is false, because soap is actually an alkali. You will notice quite a lot of cleaning products actually tend to be alkalis. Now that's not a rule for alkalis, but it is a trend that we might notice. Next question, true or false, this symbol means corrosive. Pause the video while you have a think. And the answer is true, so this symbol does mean corrosive. I'm very interested to see what drawings you came up with, so you can post them in Teams to me. True or false, sodium hydroxide is an acid. Think carefully about the chemical formula here. Pause the video while you have a think. And the answer is false, because sodium hydroxide is an alkali. And the way we can spot that is because it has that OH, those OH particles that get released to the solution. And then final true or false, this symbol means warning. So pause the video if you want to have a think. And the answer is true, this symbol does mean warning. And again, I would be very happy to see your pictures that you have come up with from that diagrams activity. Thank you all very much, Year 8, for watching. I hope it all made sense, but as always, if you do have any questions or problems, please either send me an email or put a message in our Teams on Teams, as I am still here to support you during this hour. Thank you very much.